So hello and welcome back. In this video we want to start section 6.1, which is all about exponential functions. So before I go through the examples that are in the book, basically some of the examples that or some of the concepts that are introduced in the book, I might skip them. I will go through everything that's important, but I'm going to add a few things to the book to make exponential functions more so that you can have a better understanding of exponential functions. And so in the beginning, let's start with basically let's start with understanding what exponential functions are, and then we can basically go through the rest of the material here. So basically what exponential functions are, for example, if you have a function like f of x is equal to 3 raised to the power x, this is an exponential function. Now at this point it's not important what that can be used for or what sort of phenomena can be modeled using this kind of function. For example, in the book, it's the bacterial growth. The bacterial growth population has been introduced as an example of a phenomena that can be modeled using this function. That's basically a good example. But first, let's see what this function is all about, and let's see how it behaves. So here basically you can see that I have an integer or real number or whatever you can call it, and I have raised this number to the power x. I have raised this number to the power x. And what you can see here, for example, let's start with some values of x. Let's start with some values of x and y. If here is your x and here is you have your f of x. Well, when your x is equal to 0, f of 0 is equal to 3 raised to power 0, which is equal to 1. When your x is equal to, 1, when your x is equal to 1, then your f of x is equal to 3 raised to the power 1, which is equal to 3. When your x is equal to 2, then your f of 2 is equal to 3 squared, which is equal to 9. When your x is equal to 3, your f of 3 is equal to 3 cubed, which is equal to 27. Now let's go to the negative values of x, and that is when, for example, your x is equal to -1. So f of -1 is equal to 3 raised to the power -1, which is equal to 1 over 3 raised to the power 1, which is equal to 1/3. So here you have 1/3. If your x is equal to -2, then if your x is equal to -2, then your f of x is equal to 3 raised to the power -2, which is equal to 1 over 3 squared, which is equal to 1 over 9. So here you have 1 over 9. When your x is equal to -3, for example, your f of x is equal to 3 raised to the power -3. So 3 raised to the power -3. And that is equal to 1 over 3 cubed, which is equal to 1 over 27. So this is 1 over 27. And now you have all of these values. I think hard eraser, okay. And I have to, I don't need any of this. And okay, so now we can graph this function. if you graph this function, you would get something like this. So let's say this is your I have to do it a little bit better than this. So this is your x-axis, and this is your y-axis. So this is your y-axis, and then you have your points here. So let's say, for example, you have 0, 1. So let me do 1, 2, 3, 0, 1. So this is 1, 2, 3, 1, 2, 3. And these are all very small numbers, 3 to 27. So I have 10, 30. So let's say this is 10, 20, and 30. So this is 10, 20, 30. And this is 1, 2, 3, and negative 1, negative 2, and negative 3 here. So what happens here is that you have 0, 1. So when your x is equal to 0, your f of x is equal to 1. So it's right something like here. And when your x is equal to 1, your f of x is equal to 3. So 1 and 1, 3 comes something over here. When your x is equal to 2, your f of x is equal to 9. So this is another point, 3, 27, which is something around here, somewhere around here. And then when your x is equal to negative 1, your f of x is equal to 1/3. So it's somewhere around here, very close to the x-axis. When your x is equal to negative 2, 1/9, very close again. When your x is equal to negative 3, 1/27. So very, very close to the x-axis. And then your function becomes something like this. So it's kind of hard to draw this graph in one stroke, but it looks something like this. So as you can see, as x approaches very basically negative and more basically greater negative numbers or bigger negative numbers approaching negative infinity, your f of x is tending more and more towards 0, but it will actually never become 0. It's just tending towards 0, getting very smaller and smaller and smaller. When your x is equal to 0, you have some y-intercept over here. For example, in this case, f of x is equal to 1, and then the function just starts shooting up in an exponential way. And so that's basically why this function is called an exponential function. So this is basically an exponential function, and this is basically a model that can be used for any kind of phenomena that is close to this algorithm of growth. So as you can see, for example, the value of the function at x is equal to 1 is something around 5, or I don't know, 3, or here, for example. But at x is equal as x is equal to 2, then it goes all of a sudden goes to 10, and at 3 it all of a sudden goes to something around 30, and then at 4 and 5, and it just gets basically shoots up in an exponential way, and it gets bigger and bigger. The output of the functions get bigger and bigger in a very short amount of time. So that's basically an exponential function. In the next video, I'll try to give you some examples of how this function can be used in different situations, basically some sort of real life situations, to get more familiar with this kind of function. I'll see you in the next video.